Good morning. I'm Ray Smith from Lawrence Livermore National Laboratory. I'm a research engineer that has worked with the team to do hydrogen storage for vehicles. We've got a technology called the Cryotank for storage of hydrogen as a vehicle fuel. We think it's lighter, smaller, safer, and cheaper. And we've demonstrated over 600-mile range in the demonstration vehicle shown here in this first slide of the Cryotank in the back of a modified Prius. First question, of course, is why hydrogen as a mobile fuel? And the answer is a pathway to greener mobility. Natural gas can be used to make hydrogen as it's done commercially today through natural gas reformers. Of course, you have CO2 emissions to the atmosphere when you do it that way, starting with a fossil fuel. But you can also use it by generate hydrogen, produce hydrogen from renewable solar or wind electricity and use electrolyzers to electrolyze water to form hydrogen. Hydrogen would be put into a fuel distribution system, an infrastructure that currently the U.S. does not have. From the fuel distribution system, then, you'd have the capability to fuel either fuel cell cars of very high efficiency or internal combustion engines that can have modest efficiency. Both of those machines put out just water as the emission product. Continuing on with hydrogen as a mobile fuel, renewable hydrogen has no toxic or greenhouse gas emissions. This is going to become even more important in the future. Fuel cells using hydrogen achieve greater than 50% efficiency. That allows the cost per mile to be comparable to that of gasoline. Hydrogen also has more energy per pound than any other fuel. And this means that ultimately it will be a commercial aircraft fuel. The technology that the lab has developed uses hydrogen at low temperature and high pressure to reduce weight, volume, and cost of storage. Prototypes have passed both DOT and ISO tests. On the left is shown an environmental test, and on the right is a bullet test required by the DOT to demonstrate that the pressure vessel does not shatter when penetrated by a high-powered rifle bullet. The Cryotank will store either gaseous or liquid hydrogen. The phase depends upon the temperature. When loaded, fueled, the liquid will be at low pressure and about 20 Kelvin. 20 Kelvin is very close to absolute zero. As the tank slowly warms due to ambient heat leaking into the tank, liquid and gas coexist together as the pressure rises. And ultimately, you get to the pressure limit of the vessel, and you have to vent a little bit of hydrogen. The amount of gas, and hence the pressure in the tank, depends on the duration that you don't use the car. That is the time that it's parked. No hydrogen is lost until after 10 days of parking. We call this dormancy. The vented gas can be catalytically reacted to water without any hazard at all. So you can park the car in a fully enclosed place safely. The Cryotank that the lab has developed uses insulation by putting a vacuum around the conventional pressure vessel. This conventional pressure vessel is made of carbon fiber epoxy, and it is commercially produced to make or for use as a natural gas tank aboard vehicles. Therefore, it's already passed many DOT tests. A tank that's about 40 gallons in external volume will cost about $2,800. That's an incremental cost over the cost of the car. A tank of that size would hold about 7 kilograms of hydrogen, and that 7 kilograms of hydrogen is equivalent to about 7 gallons of gasoline. Now, these cars will achieve 60 to 80 miles per gallon, so the range of the cars will be well over 400 miles, as we have in many of today's cars. The Cryotank that we've developed already exceeds DOE's 2015 hydrogen storage goals, and we think it can actually approach the ultimate weight and volume targets that DOE has set. The Generation 3 system that we've built and demonstrated is shown in the upper right portion of the diagram here. At the extreme upper right is DOE's ultimate goals for hydrogen storage in terms of volume and density. Cryogenic pressure vessels can enable hydrogen-fueled vehicles. One of the reasons is the lowest ownership cost. Cryogenic vessels use 2 to 4 times less carbon fiber than high-pressure gaseous hydrogen tanks. These tanks are being used on current fuel cell vehicles that are being demonstrated around the world. Rapid refueling is also possible with the Cryotank, and in fact, Lawrence Livermore is currently installing a high-pressure pump to pump hydrogen into the tank at in a time of less than 5 minutes. This will give us a high-density fill. The Cryotank technology is actually quite safe. The low expansion energy, because the gas is cold, is very important. And secondarily, there is a second jacket of steel around the pressure vessel, which is the vacuum vessel that protects the high pressure vessel also. So low expansion energy means it's safer. The steel jacket provides secondary protection, and you have low on-the-road operating pressure because as the hydrogen is extracted from the tank, it actually cools the remaining hydrogen that's in the tank. Fewer pressure cycles due to longer driving range means that fatigue of the pressure vessel is not nearly as much of an issue. LL&L has demonstrated in the vehicle 650 miles of range on a 10 kilogram hydrogen fill. Projected uses for the Cryotank are primarily for vehicles, as we've said, automobiles. In fact, BMW will incorporate the Cryotank technology into their fuel cell test fleet of a couple of hundred cars that will be completed this year, 2012. Aircraft, in particular Airbus, is discussing with BMW the replacement of APUs, auxiliary power units, that are used on commercial aircraft. The reason you'd want to replace the small jet engine that's used on board aircraft today with a fuel cell is you could use a Cryotank to store the hydrogen. You'd fuel the fuel cell with that hydrogen. It would generate electricity and also clean water. That water is clean enough, it can be used as the potable water on board the aircraft. The nitrogen that is the remaining gas in the fuel cell exhaust, because the oxygen has been consumed by the fuel cell, can actually be used to inert the jet fuel tanks, thus displacing any air in the top of the tanks as you use jet fuel during the trip. Forklifts, which are used inside, could be fueled with fuel cells and Cryotank technology so that you have no emissions. Mining vehicles, mining locomotives in particular, need to have no emissions, and this would also be a good application for the Cryotank. If you have questions about this technology, please get in touch with Anne-Marie Micah at mica1llnl.gov. This is Ray Smith. Thank you very much for listening to our Cryotank technology.